Hi folks, I'm going to give you a short demonstration here. This is one of my favorite places on earth. And I have yet to climb it, but it's Long's Peak. It's the highest peak in Colorado, 14,000 plus feet. Don't know that I'll ever climb it, but it's an incredibly beautiful place, close to Estes Park in Colorado. These mountains were thrust up by a major fault back during the Cretaceous, so about 100 million years ago. These mountains didn't exist and they were pushed up by Earth forces. And so we want to talk a little bit about the sort of forces that have led to these massive upheavals in mountain formation across the world. So with Long's Peak here, I'm actually going to demonstrate something here. So this book is a flat plane. A plane, as you know, is defined by 3 points, at least 3 points, right? And so a line has 2, a point has 1, right? And so with this plane, it is oriented in 3-dimensional space. As it turns out, that direction right there is north. And that being north, if I were to tilt this surface, let's say this is a rock stratum, and now it's been tilted to the north, we would say that it's actually dipping to the north. And so dip is one of these concepts about how this is inclined relative to the horizontal. So if this is horizontal, that has no dip or 0-degree dip. And if I dip it like this, that's about roughly a 30-degree dip. And so with a 30-degree dip, it's dipping to the north now. We use 2 items in order to describe what we call attitude. And one of those is the dip. The other one's called the strike. And so geologists are very used to saying this, but we just say, what's the attitude of these rocks? It's the strike and the dip. The dip is the variation from the horizontal, roughly 30 degrees, but the direction of the dip is to the north, right? Well, the strike is kind of related to that. The strike is perpendicular to that direction. I put my finger on here like this. You can actually see in my hand here that that's the dip direction. 90 degrees to that would be running across this way. And in a way, it's kind of a hinge line for how this stratum is dipping. So I could put the hinge line up here if it makes it easier. So here it is flat, 0-degree dip. Here it is with a 30-degree dip. I've actually just hinged this whole thing on this line right up here. So that's actually the strike direction here. So that's strike. The dip is the amount of variation from the horizontal, and the dip direction is 90 degrees to the strike direction. So the strike runs this way, dip direction runs that way. We define almost every geologic structure based on attitudes. So attitudes are really important for us because rock strata like this, they can become folded, which is kind of a convenient way to put hydrocarbons or water and other things in here inside of these rocks, and it traps them maybe. And so that's one of the folds that we're going to talk about. This is called an anticline. This is an anticline, and this is a syncline. There's a few more sort of things we're going to talk about too. We're going to talk about anticlines like this that are now plunging. That is, their axis is now inclined to the horizontal. Normally it'd be horizontal like this, but now it's plunging. And if we have a syncline, same thing goes. So this one's plunging towards you. This is plunging towards you, or in this case, because you know that that is north that way, this is to the west. You're on the west side here. So an anticline plunging to the west here. We'll talk more about this in just a bit here. Thanks.